Alright, here we go. Transformations. Now, we've already talked about two different types of transformations. First one we talked about was translation. And basically translation is when you slide an object from one position to another one. So, for example, I have a pentagon there, and I want to slide it over here. Notice the shape doesn't change, even though my drawing is not perfect. It doesn't change in size. All I did was slide it, and we realized that we could actually make some rules here. And the rules here could be like something like x plus 3, comma y minus 2. And what this means is that the shape moves right 3 spots, down 2 spots to its new position. So again, we don't change it. We just simply slide it across like if it was on ice or something like that. So that's translation. And then reflection we talked about yesterday. And reflection is basically when you have an object and you have a line of reflection and you reflect it across that line of reflection. And we talked about how each point is the same distance away from the line of reflection to its image. So this point here is going to be about that far away. And this corner here will be about the same distance away. So put that point there. And what about this long guy? He's going to be about the same distance away over here. So you notice our shape kind of flips across the line of reflection there to get our image. So this would be our original picture. This would be our image over here. So those are two forms of transformations that we've already talked about. Now, what we're going to talk about today is rotation. So, rotation occurs when you turn a figure around a given point. Figures can be rotated in a clockwise or counterclockwise direction. A rotated figure has the same size and shape as the original figure. So in other words, we're not changing the size or shape of the figure at this point in time, but just basically a different orientation. It's just moved around the coordinate plane a little bit. So when figures are plotted on the coordinate plane, the origin can be used as a center of rotation. Every 90 degrees of a figure is rotated around the origin and moves each point in the figure to an adjacent quadrant. So back in the fall, we talked about quadrants. We talked about how when you take an x-axis and a y-axis and you intersect them, you end up with your 4 quadrants. So we start here in quadrant 1. This is the quadrant everyone likes because everybody's positive in here. Then we go counterclockwise to quadrant 2, counterclockwise to quadrant 3, and counterclockwise to quadrant 4. Okay, so what we're going to be talking about today is moving objects or rotating objects either 90 degrees, 180 degrees, or 270 degrees. And one of the things that you're going to have to do today is turn your paper like 90 degrees or 180 degrees. Okay. And to just turn your paper 90 degrees, you would just turn your paper left one turn. So if you could turn it 4 times all the way around, it would be back to where it began. So you're just going to turn your paper 1/4 of the way around. So it'd be like if your paper was like this, turn it 1/4, it would now be like this. That's a pretty bad drawing. Let me try that again. It would now be something like this. It would now be on its side because you turned it 1/4 of the way around. So that's going to help us determine the new locations of our objects. Okay. So let's take a look at the next page. So we're going to start off with some dots. So in number 7, we're going to graph the image of point T, which is located right here. We're going to make a 90-degree counterclockwise turn. So 90 degrees counterclockwise. So obviously on a clock, this is the way a clock turns normally. Counterclockwise is the opposite direction, so we're going to go this way. So we're going to turn this counterclockwise 90 degrees. So that means you're going to take your paper and turn it 1/4. Now when you go 90 degrees, your point is going to start in one quadrant and it's going to end up in the quadrant right next to it, to the left, because we're counterclockwise. So now we need to figure out where is that going to fall. Well, what I did here is I took a picture of this paper and I actually turned it 90 degrees. So you can see I've turned it 90 degrees. So go ahead and turn your paper 90 degrees and see if your dot ends up in the same spot my dot does. So hopefully if you have that, you can now figure out where that dot is. So what I'm going to do is I'm going to use my little pointer here. I'm going to count 1, 2, 3, 4, 5 across, and up 1, 2, 3, 4. So my new dot, or my new image, is going to be across 1, 2, 3, 4, 5, up 4, 1, 2, 3, 4. There's where my dot's going to fall, right here. So there is its new point in the coordinate plane in quadrant 2 at the point -5, 4. And I can see that again by turning my paper sideways to the left 90 degrees. Let's take a look at number 8. Now number 8, here's where we're going to start. We're going to start down here in quadrant 3, and we're going to turn it 270 degrees around the origin. So that's like 3 turns. So this would be 90, 180, 270. So which quadrant do we end up in? We end up in quadrant 4. But another way of saying this, or kind of taking a shortcut here, would just be like taking 90 degrees counterclockwise. So you can either turn your paper 3 times to the right, to the left, or just take your paper and turn it to the right 1 time. So when you turn your paper, you should end up with something like the following, with your dot now in quadrant 4. It's now in the bottom quadrant. So again, this helps us locate where this new dot is after this rotation. So I'm going to see if I can figure that out. So 1, 2, 3, cross, down 3. So I'm going to come back over here to our original graph. 1, 2, 3, then down 3. And there is where my new dot is going to be. Let me get rid of all that. And again, I got that by turning my paper 1/4 turn to see where the new dot's going to be in quadrant 4. Okay, let's take a look at number 9 here. Here we have dot C. See if you guys can figure this one out on your own. So I'll give you a couple seconds here to hit pause and see if you can figure out where dot C now belongs. So go ahead and do that one. Okay, so here I've turned my paper 90 degrees counterclockwise, so I'm going to turn my paper this direction. And when you do that, you know that this dot is going to be somewhere down here in quadrant 3. So when you turn your paper over, notice my dot is now in quadrant 3, and I can figure out what point that is by starting from the origin. So I know it's over 5, down 4. So go ahead and find that. So if I go over 5, 1, 2, 3, 4, 5, down 4, 1, 2, 3, 4. And that is my new dot after a 90-degree counterclockwise turn. Okay? So again, if you're having trouble turning your paper, you're not quite getting the same image I'm getting, feel free to raise your hand and hopefully someone will be around to help you. Okay, let's take a look at the next page. Alright, this next page we're going to deal with my boy Ted. Everyone say hi, Ted. Hi, Ted. He's our little smiley guy here in quadrant 1. And of course, he is smiling because he's in quadrant 1 because everything is positive in quadrant 1. Okay, so the first thing we're going to do is we're going to focus in on Ted's eyes. So take a look at his eyes. We want to write down the ordered pairs or the coordinates of Ted's eyes. So now his left eye, which is this guy right there. What is the ordered pair for his left eye? His left eye ordered pair is 6, 5. And then his right eye is that guy. Sorry, Ted, if I'm poking you in the eye. His ordered pair is 4, 5. Okay, so what we're going to do is we're going to rotate Ted throughout the coordinate plane, 90 degrees, 180, 270. I just want you to take note of what's happening. Don't worry about doing the work. I'm going to do most of the work for you. I just really want you to observe what's happening to Ted as we rotate him. So here you can see our quadrants, 1, 2, 3, 4. Let's move down to Ted. Here we've rotated Ted 180 degrees and his whole world's flipped upside down. He's now in the all negative section and he's no longer smiling. Okay? But we want to first find the quadrants for Ted's left eye. So Ted's left eye is this guy right there. So his quadrant, or his ordered pair, would be -6, -5, and the right eye's new ordered pair would be -4, -5. Okay? So when we take something and we rotate 180 degrees, what do you notice about the ordered pairs? Take a look here. Here's our original ordered pair, 6, 5. Our new ordered pair is -6, -5. Original is 4, 5. Our new is -4, -5. Now, hopefully you've recognized the fact that both numbers turn to their opposites. 6 becomes -6, and 5 becomes -5. Same thing with the green numbers. The green numbers both turn to their opposites. So what we can say here is when you turn something 180 degrees, your ordered pairs just go to their opposites. They don't go to their negatives. That's not what it's saying. It's saying they go to their opposites. So if they're positive, they go negative. If they're negative, they go positive. So this is one of the first rules. Now these rules you don't have to memorize, just trying to give you a basic background as to some of the rules of this rotational symmetry. Okay, so now let's take a look at Ted again. Ted's having a little fun here. So now we're going to rotate Ted 90 degrees counterclockwise. So he's going to go that direction 90 degrees. So what are Ted's new eyeball coordinates? So Ted's left eye quadrant is going to be, coordinate is going to be -5, 6. And his right eye, which is that guy, is going to be -5, 4. Okay, so if you go back to the original ordered pairs, which were, I'll just run down quickly, the original ordered pairs were 6, 5 for lefty, and 4, 5 for the righty. How do they compare? Well, one thing that you should notice is that they've now flip-flopped. So for example, 5 was the Y, now it's with the X, 6 was the X, now it's with the Y, but you'll also notice that now we have a negative number. So the rule for moving an object 90-degree rotation is the following. Your Y value, the opposite of your Y value comes first, followed by the X value of your ordered pair. Now again, I get that this is confusing, but I'm just trying to give you some background. You do not have to memorize this, so do not panic. And then finally, what happens if you make Ted and you turn them 270 degrees or 90-degree rotation clockwise. So here's where Ted was. We just moved him down here, either by going 270 this direction or 90 in the opposite direction. So Ted's new left eye and right eye coordinates are as follows. So we have 5, -6, and 5, -4. So again, compare that to our original guys. And one of the things that you should know is that again, the X and Y's flip-flop, but now the X value has become the opposite, where up here it was a +6. When you look down here, it's now a -6. So the rule for the 90 degrees clockwise would be the following. Y value now comes first, and the opposite of your X value comes second. So here are the rules located down here for all 90, 180, and 90-degree counterclockwise turns. The ones that I think is not really a memorization thing, but it's certainly something you can remember. 180-degree rotation just means make your ordered pairs the opposite of what they were. Okay. For the 90-degree ones, just turn your paper. That's probably the best advice I can give you without having to memorize all the different rules. Okay. So let's take a look at some examples here. Now I'm not going to do all these. I'm just going to do a couple of these just so you can kind of see what's going on. So I want to take this shape and rotate it 180 degrees about its origin. Well, like we said, when you rotate 180 degrees, everything just goes to its opposite. So you can see what I did here was I turned our paper 2 times. So 90 degrees twice. And you can see now the new image. You can see F is now down here, and is now in its opposite quadrant, so they all go to their opposite quadrants here. So what you can do to find the ordered pairs, since I know they're all opposites, I'm just going to do a couple of these. Let's take a look at F, which is right here. Its ordered pair is 1, 2, 3, 4, up 2, so its ordered pair is negative 4, comma 2. So its f prime would be then the opposite of that, which would be 4, comma negative 2. And if I look on my little picture here, 4, comma negative 2, so over 4, 1, 2, 3, 4, down 2, 1, 2. There is my new f. So f prime would be, on my paper, would be something like 1, 2, 3, 4, down 2. Would be right there. Okay, this will be f prime. Okay, let's take a look at n real quick. N's located right there. Its ordered pair would be over 1, down 2. So it's negative 1, negative 2. Well, n prime would just be the opposite of that, which would be 1, comma 2. So over 1 up 2. This is now n prime, and you can see it also is in the same spot. So you get a very similar picture to what you see there. So when you're done, you'd end up with something that looks something similar to that. So 180 degrees, just turn all the ordered pairs that are opposites, and then redraw the picture. Okay, take a look at number 3. Rotating 90 degrees counterclockwise. So we're going to be going this direction 1 turn. So take your paper and just turn it one quarter turn 90 degrees counterclockwise. So the opposite direction of a clock, and you get this picture here. Okay, so hopefully what you have on your desk matches what you see inside this red circle. So now you can see what this object is going to look like. So now I can just simply find these 3 points and just plot them back on my picture, on my original coordinate plane here. So let's start with x right there. So x's ordered pair would be 1, 2, 3. I'm sorry, over 2, down 3. So I'm going to go over 2, 1, 2, down 3, put my dot. Okay, then you're going to do, I don't know what that is, I'm going to guess a W, maybe, whatever this guy is. And that one, I'm going to go over 1, 2, 1, 2, 1, 2, 3, 4, and down 5. So I'm going to do over 4, down 5, it's right there. And then the last guy is just to the left, right there. So I know my drawing, it's a little bit harder to draw these on with a stylus than probably you guys have with a straight edge. So it should look something like that. Again, it should mirror what's in my picture. And then finally, the last one on this page, I'm going to rotate this 90 degrees clockwise. So I'm going to go in that direction. So you can see I've turned my paper already. So go ahead and turn your paper to make sure that you have what I have in this red circle. So let's get our new points. So let's start with V. We can see V is right there in the picture, in the green circle. So how do I get that? I go over 1, down 4. So over 1, down 4. So that means I'm going to go over 1, down 4. So I'll put a dot right there as best I can, and that is our V prime. How about K? K, which is located right there. Where is it in my picture? Well, it's located right here. Okay, so what ordered pair would that be? That would be 1, 2, 3, 4, and down 2. So I'm going to go over 4, 1, 2, 3, 4, down 2. So there's K. And finally, the last one, J. Take a look at what J is. J is up here. Okay, J was in the 3rd quadrant. It's now moving up to the 2nd quadrant because it moved 90 degrees. And it's simply over 2, up 1. So I'm going to go over 2, up 1. And then connect all 3. So again, it should look something like my picture over here. So again, work on trying to turn that page and trying to imagine what the new shape is going to look like. Hopefully that gives you an idea of where to draw your new image. Okay, let's take a look at the next page. Okay, so on this page what you're going to do is try to guess what the rule is. So I'm going to do a couple of these with you, and then you're going to do the rest on your own. So basically, is it 90 degrees? Is it 180? we'll call this clockwise, or 90 degrees counterclockwise. So take a look at the original. So here's K here. Where did K go? It just moved over one quadrant to the right, and that's clockwise. So this one would be 90 degrees clockwise. Take a look at number 8. Let's just find a point. Here's Z. Well, where's Z on the image? It's down here. Well, notice it's moved over 2 quadrants. It's in the opposite quadrant. So that would mean that this one is 180 degrees clockwise or counterclockwise. Doesn't matter because you'll end up in the same spot. 180 degrees rotation. Okay, and then I'll do this next one here. So pick a point. So here's T. And where is T prime? Well, T prime's right there. It moved over one quadrant to the left, which is counterclockwise. So that would be 90 degrees counterclockwise. So go ahead and try 10, 11, and 12 on your own. Go ahead and hit pause. Well, as you can see here, that must not have been too much fun. They were all 180 degrees rotation because they start in one quadrant and they end up in their opposite quadrant. So the 180 degrees of rotation. Okay, take a look at the next page here. So basically you want to determine is if these were true rotations. Was there an actual rotation here? So for example, in number 7, one thing I noticed is that the shape is smaller. So this cannot be rotation. So we would say not congruent because they're not the same as the one shape that got smaller. Moving over to number 8, what this picture appears to be is 180 degrees rotation. Everything's gone to their opposites. Okay, you can see that the short side up top is now the short side on the bottom. And so everything looks like it's gone to the opposites. So therefore this would be, yes, that is a rotation of 180 degrees. Take a look at 9. I'll tell you what, go ahead and look at 9 and 10 on your own. See if you can see if it is a true rotation in 9 and 10. Okay, so look at 9. 9 is, yes, that's just a 90 degree rotation there. They just kind of rotated 90 degrees. And 10 is a little bit difficult to tell, but if you just take one point, pick its ordered pairs, you'll notice that its opposite is there. Again, if you take any of these, find its ordered pairs. For example, this is -5, -2. That means I go +5, +2. Its opposite is there, so this would be 180 degrees of rotation, so that would be a yes. Okay, so just to review a little bit, just make sure that you guys are working on turning your papers 90 degrees either left or right to kind of recognize your 90 degree rotation and where the location of the new shape should be. So your homework today is the rest of the packet. Go ahead and answer the following. Some of them are multiple choice. If you have any questions, feel free to ask. Okay, so good luck and have fun.